Today we're looking at computer networks, what they are, how they work, and the vital role they play in the work of any business. To get a clearer understanding of just how vital networks are, we're going to take a look at their place in one of Australia's online business leaders, Destra Corporation. We'll examine what a network consists of, the range of processes and procedures used to establish it, network architecture and how that is decided, the network infrastructure requirements, and the network procedures that keep it running smoothly. But first of all, what is a network? Well, put simply, when any two or more computers are connected to each other, you have a network. The purpose of a network is to enable the sharing of data, files and information between systems. In today's workplace, this is a key need of many workers, sharing and accessing information in real time, communicating with each other and updating records and information instantaneously. Computer networks can be connected through cables or phone lines, or wirelessly using wireless networking cards that send and receive data through the air. There are a number of types of computer networks, but two of the most common are local area networks, connecting computers close by, generally in the same building, and wide area networks. These are networks linking computers that are further apart, generally connected by telephone lines or radio waves. Destra Corporation is a publicly listed company that runs a number of businesses. It has two main streams of business, business services and entertainment services. Their business services include website hosting, providing dedicated servers and networks to businesses, and internet domain registry. Entertainment services include providing technology to record labels and retailers, allowing them to sell music online, providing technology which allows record labels to deliver music to radio stations online, and a website allowing independent bands to publish their music online. In short, Destra is a dynamic, emergent business that relies on networks not just for their own needs, but the provision of their services to others. As well, providing online services to other companies, they are often required to design and create networks from scratch. Looking after all the technical stuff at Destra is Adam Kia, Chief Technology Officer. Because of the nature of their business, providing online services, Destra has some pretty special characteristics.
Yeah, definitely. We obviously don't have any shop fronts. We have offices in which we conduct business out of, but our shop front is effectively on the internet. So providing 24/7 access uninterrupted to the businesses is paramount, and that's primarily conducted over the internet and then edging onto our networks that we operate throughout the country.
10 years ago, Destra started life as a software development house, then became an online resource provider, incorporating their networks over the top of this.
We actually came online as a dial-up ISP. We then switched over to fibre access and still housed our computers internally within our business. And I guess over in the recent years, as the operation of the networks has become more fundamental and we require a higher level of availability, we've moved into internet data centres, so buildings that are built specifically to house computers that are connected to the internet and provide us access more directly to the backbone.
So, what does the network at Destra actually consist of?
The building here obviously has a local network, and that network services all of the different users within the network, and it backs into our foreign networks or networks in a remote location over a dedicated link which runs at 2 megabit. That link then is firewalled at both ends to ensure that there's a level of security and people can't get into the corporate network from the internet network. And then the internet network is further firewalled out into the public internet to ensure that we're able to restrict access there as well. There's a series of other connections running out of the building up into Sydney to allow VPN access and directly connect the different offices.
So that's a bit about Destra and what their network consists of. Let's recap. A network is two or more computers connected to each other. Networks allow data sharing between computers and users. They can be connected via cables, phone lines or wirelessly. Let's have a look at the processes and procedures used to build and maintain a network. Firstly, how do you decide what a network will consist of before it is built?
We have a saying, and it's quite common in computing, and it's called an axiom of three theory. And you effectively have cost, you have security, and you have usability or availability. And you really get to choose two of those, and it's a matter of trying to balance those. Generally, security will always win, and generally, usability is compromised by security. We have to balance it from a commercial perspective. Obviously, if you have infinite cache, then you can solve both usability and security to a tolerable level. But we have to sacrifice in some circumstances an aspect of usability to ensure that there's security in place.
Having decided on the appropriate balance between security and usability, decisions about network requirements are placed in the hands of engineers and senior management.
Senior management is always involved, I guess, in the requirements for the networks. The engineers usually liaise with senior management to understand, I guess, what cost tolerance there is for a particular project, what the core goal is.
Having decided network needs, Destra relies mainly on in-house staff, not outsourced experts.
If we restrict the level of vendors that we work with and retain, I guess, our team members for a longer period of time, we begin to generate what we call domain knowledge or a level of expertise in a particular area. And we find that investing in the team members and investing in domain knowledge gives us a better result than continually working with a variety of outsourced companies.
Having established a new network, a crucial part of the process involves following up and reviewing.
We go through a quality assurance process, so we go through a process of testing the systems and ensuring that what we've designed, once again, actually meets the requirements document. And we find that that produces a complete circuit as far as, inception, requirements and communication, design and the technical phase, the implementation, the actual doing, and then evaluation. So actually looking back and saying, did we actually meet the goal we started with?
Network needs analysis is based on cost, security and usability. This is commonly known as the axiom of three. Based on these principles, senior management decides the specific network composition. They consult with engineers and staff. Using in-house staff rather than outsourced workers generates expertise. Any new network requires follow-up and review. Network architecture refers to the design and structure of the network. How a network is designed or structured is crucial to its success. Common key factors to many networks are availability, speed, and wired or wireless options. In the case of Destra, their network has unique and high-powered needs which must be addressed.
Each of the different business units that sit under Destra have their own different websites and they have varying requirements. Things like mp3.com.au and Destra Music have huge arrays of music, terabytes and terabytes and terabytes of collections of MP3s and Windows music files and Windows media files and the like. In those circumstances, we're really operating different hardware and network environments to service the different business units and their requirements. Everything from standalone servers for some of the smaller business units that are primarily information repositories to quite complex, clustered, highly available networks.
The backbone of their various networks is the intranet, the internal or private network that connects all 85 staff to each other and Destra data, and is also accessible to authorised clients.
Currently, the intranet incorporates obviously email, it incorporates shared calendaring and collaborative tools. we're taking the intranet to the, an extended level at the moment and trying to offer portal access where users and internal team members are able to build their own view of information within the company, able to publish documentation and provide versioning over that documentation, able to collaborate in team sites, so cluster together common users and allow them to work collaboratively on a particular goal and be in control of that process and that information, independent from their managers, and to promote the clearest channel of communication within the business, and then to take portions of that and face it out to our partners as well and allow them extranet access, so restricted access to the intranet, so they're able to also participate in the projects that we're performing within the business.
As we know, one of the key aims of any network is the sharing and updating of information and data. Today, one of the workplace's main communication tools is email, and the successful provision of this is crucial to any network.
We host several different mail servers. We host internal mail server for corporate requirements. Then we host a shared mail server for our customers, which is distributed across 4 different machines, housing around about 45 different disk drives. So you're effectively writing and reading from your disk arrays at incredible rates.
As well, part of network architecture is knowing when the network is going to have the most demands placed on it and to plan accordingly.
Our traffic is cyclical, like all networks connected to the internet. Traffic follows the sun. As the sun goes up and down, you generally see a wave of traffic throughout the day. Our peaks begin at around about 6:30, 7 o'clock in the morning as people come online for the different jobs and the like. They can't rely on them 100%, but if you look at that over a longer period of time, it's incredibly cyclical, incredibly predictable, which is very helpful for budgeting and for forecasting growth and hardware requirements.
So how is the network actually structured?
Okay, within the network layers there's a variety of different pieces of equipment. At the head of the network there are routers. Sitting behind those routers there are firewalls to restrict the access. Firewalls provide a first line of defence but don't necessarily have an understanding of the traffic that they are letting into the network. Sitting behind the firewalls, we sometimes operate IDS devices, which are intrusion detection systems, and they're able to actually inspect the traffic and make sure that when we're letting it through ports on the firewall that it actually meets stated protocols requirements, and if not, drop the traffic at that stage. Then sitting behind this is usually a series of switching equipment, which is generally VLAN or divided up into different segments, and then connected to the switching equipment are generally application servers, so the servers that people are accessing that provide access to applications and processing capabilities. Attached to them in some circumstances will be storage devices if the storage requirements are beyond what a general server is able to provide. The devices that are going to allow quick and easy restore of the application servers in the event that they do fail.
The failure of a network is as important to take into account as its successful operation.
A fact of life is computer parts fail. They have moving parts in them. Anything that moves is eventually going to break. It's not uncommon at all. So we try to accommodate the fact that things will break and ensure that things are run in a high availability environment, that they have redundant pairs. Sometimes they can be in an active-passive arrangement, so where one's actually active and operating and there's a passive device sitting next to it waiting for the other one to fail. Or in other circumstances we'll deploy things in active-active, and in those types of circumstances you distribute load or the pressure on the systems across the devices and basically still have an opportunity for one to fail and continue to operate the systems.
Network architecture refers to the design and structure of the network. Major components may consist of routers, which move data along networks, firewalls, which prevent unauthorised access to networks, an intruder detection system, which inspects network activity for suspicious patterns that may indicate an attack, switching equipment, which directs data to its required destination, application servers, handling operation between users and databases, and storage or backup devices, disk or tape devices that save data. The intranet is the internal or private network that connects staff to each other and is also accessible to authorised clients. Email is also a vital component of a network. Good network architecture design involves knowing peak times of network use and allowing for network failure. Network infrastructure refers to the physical hardware used to interconnect computers and users. Infrastructure includes the transmission media, such as telephone lines, cable television lines, and satellites and antennas. It also includes the routers, aggregators, repeaters, and other devices that control transmission paths, and the software used to send, receive, and manage the signals that are transmitted. For Destra, choosing infrastructure for any new network is reflective of their professional goals and standards.
Things like switches are generally quite cheap, and we'll usually buy a high quality, high speed switching and ensure that we don't need to change that switching over time. Routers and firewalls generally are priced based on their capacity for speed, for how much data they're able to process. If we're building out a network head or a corporate portion of the network, then we'll generally over-invest to ensure that we don't need to decommission and repurchase equipment as the company grows. If we're building out customer requirements, we generally fit the devices quite tightly to their requirements to ensure that we're able to minimise expenditure for them. And by using a consistent set of hardware across the customer base, as they do grow, we're able to decommission that, provide it to another client, and then upgrade their equipment.
Obviously, with a network so large, doing so many things in real time, high-quality fast servers, the devices that manage network resources, are critical.
I think we operate around over 750 servers spread across 3 primary locations. The computers are divided amongst those different facilities for a variety of different reasons, be it generally security and cost consideration. Each of the different facilities have different strength networks, have different strength physical security, so the limitation of access to the physical devices, and we make considered judgment as to where we'd put the devices.
As well as powerful and numerous servers, Destra has a need for a comprehensive wide area network. A network of computers spread across a number of locations.
Wide area network requirements for the business really revolve around connecting offices and ensuring that we're able to carry data in a cost-effective means across a private and secure network.
As we know, in any network, security is paramount, and this needs to be reflected in the infrastructure. We hear a lot about firewalls, but they are not the be-all and end-all of security.
There's generally a misconception in the industry that firewalls are a panacea to security. What firewalls don't do is generally inspect the type of traffic that's coming into our network, and there's a misconception that if you firewall port 80, the only thing that's going to come into your network is web traffic. Web traffic or HTTP operates on port 80. There's actually nothing in most general firewalls that restricts the type of traffic that's coming in, so people can actually tunnel any traffic through a firewall. What we generally find is a requirement to also couple inspection devices that look at the type of traffic that's coming through a firewall and ensure that the traffic is the protocol or type of traffic that we're expecting, to ensure that people are not tunneling promiscuous applications through our firewalls.
Another crucial aspect of infrastructure and security is ensuring that power changes or disruptions don't disrupt the network's ability to perform.
In all circumstances, we generally look for conditioned UPS, so UPS services that are able to level out and even out power, be it through spikes or through brownouts or drops in the power requirements. We then also look to ensure there's adequate generators on site with adequate fuel supplies to ensure that if there is a complete blackout, that they can switch over to a primed or ready generator, and that they have sufficient fuel to last throughout any disruption period.
Network infrastructure refers to the physical hardware used to interconnect computers and users. This includes everything from transmission media, such as telephone lines and cabling, transmission path devices, such as routers, repeaters and aggregators, and the software used to send, receive and manage signals. Destra operates over 750 servers. Security and consistency of power are both key considerations in deciding infrastructure. Network procedures refers to the good work practice by staff and managers to ensure the health and security of the network. These take a number of focuses. Firstly, because a network by nature shares a lot of information and is commonly attached to the internet, antiviral procedures are vital.
As people are operating on their desktop, they're bringing in foreign material, so material that they may have worked on from home, plugging in laptops that have obviously strayed off the premises and have been exposed to the internet, potentially even without firewalling or directly connected to the internet. So we're always ensuring that we're installing adequate software to both monitor the traffic internally within the corporate network, looking for signs or signatures of virus or Trojan activity, and also ensuring that we distribute out just general antivirus tools that are integrated into mail and integrated into file access to make sure that content that they're accessing is not malicious. We do operate anti-spyware software just to make sure, once again, that Trojans are not active on the networks. In a lot of circumstances, if someone's determined, they can custom build Trojans, and spyware is not going to detect that. You can begin to inspect traffic on the network and look for anomalies or protocols that are not generally seen in the baseline of traffic, and that can give you an opportunity, I guess, to detect promiscuous applications that maybe spyware, things like Spybot and those sorts of things, are not quite aware of.
As well, integral to a good level of security are passwords and procedures.
Password policies are enforced by the systems themselves, so generally we're looking for a fixed or a minimum length of password. We're looking for complexity of passwords, so the combination of uppercase, lowercase, symbolic characters, words that don't appear in common dictionaries and the like. Those are enforced by the directory controllers, and the change of those are enforced by the technical systems as well to ensure that passwords don't go stale.
The physical security of a network also plays a crucial role in network procedure.
Security both for our office, swipe card access to front doors, which is time locked. Also swipe card access to the internal communication rooms where we house our PABX phone systems and internal servers. And then a high level of access, permanent security guards, all the way up to biometric restrictions in some of the facilities. So circumstances where we're using palm readers and even things that weigh you in our Sydney facilities to ensure the correct person's getting access to the correct environment.
Knowing the limitations or vulnerability of a network also generally involves a good backup procedure, even off-site storage of archives.
Depending on the requirements, sometimes we use what you call NAS storage, so it's boxes with a huge amount of hard drives in them, and we back up onto those.
Whilst avoiding security breaches and accidental damage is part of good network procedure, no network is ever 100% safe from disaster. That's why you need a disaster recovery plan.
Disaster recovery is an important consideration when going through your design process. So I guess during the requirements phase, we figure out how critical a piece of equipment is and what requirement we have for restoration, and that guides us in our disaster recovery approach to each individual project. Some equipment cannot go down, so it's designed in a high availability environment, so if it does fail, that there's coupled or redundant equipment that's able to become active while we're sourcing replacement parts for that failed equipment. In those circumstances, the disaster recovery is really about the continued operation or replacement of failed componentry. In other circumstances, there is also a tolerance to downed equipment. So in event that low priority file stores, those sorts of things fail, then we'll usually have disaster recovery arrangements with our vendors to ensure we're able to have same-day business replacement, maybe next-day business replacement, or even up to 3-day business replacement, really depending on the criticality of the system.
And, as you'd expect, keeping software up to date is crucial.
Patch management and software maintenance is a critical part of operating the network. If the applications sitting upon a robust network are not maintained and kept up to date, then they're open to exploitation through vulnerability.
Network procedures refers to the good work practice by staff and managers to ensure the health and security of the network. Antiviral and anti-spyware procedures are vital, as are password and physical security procedures. Overall security is enhanced by backup procedures and off-site storage. Network procedures include a disaster recovery plan. Patch and software management is vital. Networks. Knowing what they are, how they work, and the vital role they play in the work of any business is crucial to your understanding of the modern computing environment.